All right, hello everyone. Today I'm going to go over Python and discuss some of the basic fundamentals of Python, as well as give you examples for how to do certain actions and some of the main functions and processes and procedures within Python. My hope is that by the end of this video, you're pretty confident with using some of the basics of Python, and it's important to remember that as you build upon the basics, you will, or I should say, what you're trying to do is you're trying to develop a mindset for how to systematically approach problems that require a programming solution. And so, what that means is how you think about how you write your code or what types of code blocks are required in order to complete a process become much clearer and more evident to you as you keep working with Python as a programming language, or really any programming language. Python, in and of itself, is not that difficult to learn. I understand that it's daunting for a lot of people because wrapping your mind around programming and code can be difficult. But really, it's about learning the basics and then developing what is called the programmer's mindset, which, as I just described, is essentially thinking through problems programmatically and understanding when you need to use certain types of functions or methods or even different packages that you can import into Python in order to complete a task. And so I'm not going to give you all of that in this video. I think doing that in one video is pretty hard to do. But what I do want to try to accomplish in this video is just to get you a basic understanding of what you can do in Python and some of the most very fundamental and basic operations that can be conducted. So to begin, Python is a scripted programming language. And what that means is that everything that you write or type out, scripted programming language, is essentially run and interpreted on the fly. And so there is no compiling of the code. For other programming languages like C, Sharp, C++, they require compilation. Basically, the code is turned into machine code and then run on the computer. With Python, the code is already interpreted in some way, and it's just being run after you have written it without any type of compilation being required. That's not entirely relevant to what we're doing for our purposes, but I thought I should point that out because there are benefits to that in terms of simplifying how you can debug things and test different code snippets without having to go back and constantly compile code and run things and then debug again. Nowadays, that's really not a huge issue. The time it takes to compile certain pieces of code can be pretty long, but nowadays it's pretty fast given new hardware and programming paradigms. So let's begin. The first thing that everybody needs to know with Python is comments. And to make a comment, you use the hashtag or pound sign, and then everything after is going to be a comment. So you can see I put scripted programming language up here. I can also press enter and I can say, this is our Python tutorial. And what a comment is it allows you to communicate something that you're doing without the Python interpreter actually running it as code. So if I press play here, you'll see nothing happens. Just shift enter to run the code as well. Nothing happens because there's no code there. So let's start with the first and most powerful thing in Python that you'll ever use, and that is variables. And so variables are essentially, you can think of these as containers that hold information. That's the simplest way of thinking about it. And a variable can be anything, although there are times where this may conflict. But to just keep it simple for now, a variable can be anything. So I can say variable 1 is equal to, we'll say, my name. And so now if I press Shift Enter, it'll run, and variable 1 has been assigned the value, which is the string of my name. And so what if I want to get the information inside of variable 1? I want to see what's inside of variable 1. I can come down here and I can say print variable 1. And now if I hit Shift Enter, you'll see the output beneath our cell here is my name, because I asked it to print what was placed inside of variable 1. So pretty straightforward there. Variables can contain any type of information, and so that will take us to our kind of second section here, which are going to be data types. So when you're working with data, really any data, even if you're working outside of Python, you're going to come across different data types. The first data type is going to be integers. And these are numbers that are whole. And so that's going to be, we'll say integer. And we don't want to use integer. So this is a good time to bring up. So this is already, the word integer is already being used for something else. So we may not want to use integer because we could overwrite it, and that probably wouldn't be a good idea. So I will call this, say, I1. I1 is equal to 4. So that's an integer. Just the number 4 is an integer. That is a whole number value. So why are you saying that? Well, because there's another data type called floats, and you might see it described as doubles or something else somewhere else, but typically I know it as a float. And so I'll say F1 is equal to 4.5. And a float, as you can see, is simply a number with a decimal value after it. So 4.5, it could even be 0.15 or 0.5. That would always be a float. The next data type that you would come across are strings. Oops. And with strings are essentially just text. So you can see my autocomplete here is already trying to help me out. S1 is equal to my name. And so a string is basically going to be labels for different places, your individual statements, input information for different texts. So names, addresses, all of those will be strings. And our helpful autocomplete also went ahead and gave us the last data type, which is Boolean. And Boolean is simply true or false. If you ever hear somebody say something Boolean, this simply means true or false in terms of its value. Data types are pretty important because as you continue to work on your Python skills, you will likely do a lot of arithmetic, and you need to understand that integers and floats, in some operations, you can't utilize them together. For certain functions that you use in Python, you'll get an error saying the value is a float, and really all it's saying is that some of the values in the database that you're trying to utilize are written like this, and maybe you're trying to evaluate them or compare them to integers, and it's throwing an error because of how the function is written. There are ways to convert integers to floats. Very simply, you have a 4, you can make it a 4.0, which doesn't really change the value all that much. So when the time comes and you are faced with problems that deal with those, keep that in mind, that there are integers, floats, strings, and booleans. B1 is true, and B2 is false. And you can use these for a number of different functions and features within Python. So the second thing that I want to bring up for Python as well, before we proceed, is how you write Python also matters quite a bit. Python is very case and format sensitive. So if you have a random indent, you could cause issues. And so you see I tried to run this and it says indentation error, unexpected indent. Python expects all of your indents to be very clean and formatted properly. If you have indents that are not, you will get errors that say unexpected indent. And you can indent with the tab key. In a lot of development environments like Google Colab, most of the time the IDE will automatically indent for you, but there are cases where maybe you paste in some code and the indentation is off. In that case, you can just come back and backspace to fix the indentation, or you can use your tab key to fix the indentation. Okay, so for the next thing that we want to cover here is going to be arithmetic functions. And this is going to be your very simple kind of, addition, multiplication, so on and so forth that you've seen tons and tons of times. So let's start with, we'll say cost is equal to, we'll use an example. I always like using food as an example. So let me redo this here. We'll say burger is equal to $5. And I'll make another burger. We'll call this the Big Burger. Big Burger is equal to $15. Let's say $10. Prices are absurd these days, but we don't want to go that expensive. Big Burger is $10. Burger is $5. We'll say fries. It'll be $3, and beverages or beverage will be $2. And we'll make this a float for fun. So we have some values here that give us, kind of a baseline of what we can do with some of these arithmetic functions. So the first one we'll cover is addition. And for arithmetic functions, it's just like you're working on your calculator. No different from that, really. So you could put in 5 plus 5, 5 plus 5, and you get the value of 10. Another thing you can do is you can use our variables. So I can say burger plus Big Burger, and then shift enter, and we get a value of 15. So why didn't it show the 10 as well? Well, I'm not explicitly telling Python to print any of this out. So it's just going to give the output of the very last line of code that it runs. In this case, that's 15. So if I do say print 5 plus 5, and I say print burger plus Big Burger, and now you can see I get my 10 and my 15. So I get both outputs when I explicitly tell Python to print it out to the terminal. And that is pretty helpful to know, because in the future, if you have multiple values or outputs that you want to see, you do have to call those explicitly to make sure the Python interpreter gives you everything that you asked for. All right, let's go to the next one, which is subtraction. And so let's say I want to do Big Burger minus burger. And of course, I need to wrap this in a print. And now I get my 5. And there's also division, multiplication, and did I forget one? I'm always forgetting. We can say exponents. Oops, too many X's there. So with division, again, pretty straightforward. We can do Big Burger divided by burger. We get a 2 as the output. And for multiplication, I can say, let's say I was asked to bring back beverages for the class. I can do beverage times 30. There's 30 people in my class. So I'm going to pay $60 for beverages for the class. And then exponents, I could say beverage to the, no, not that one. I'm getting confused. There we go. Beverage cubed. And so that's $8. There's also one that you may use and you may not use, but it is very helpful to know, and that's the modulo operator. It's essentially the remainder, if you're looking for the remainder of a value. So let's say I want to know how much money I will have left after I buy. Let's say I have a coupon that will take the cost of a beverage off of my burger. So burger modulo beverage. And then I run, and that would be 1. So why is it 1? Because the modulo divides. So it divides first, then gives the remainder. Excellent. And with that, you basically have all of your arithmetic functions that you need in order to work with Python math. And there are some more complex topics that we will cover later on. But for now, this is essentially what you need to know. Once we start messing with data matrices, we'll we will be stepping into some linear algebra, but it's really not that complicated. And especially if you can kind of abstractly visualize the matrices, it becomes way more simplistic to break down linear algebra as you go. So what's the next thing that we need to cover? Let's go with lists. So lists are pretty helpful because you can think of lists, and I know lists just makes it kind of confusing because when you think of a list, you think of something just kind of written down in order on a piece of paper or something. But lists in Python are essentially containers that hold multiple variables. So with variables, we have any word, text, or anything that we type, a key essentially, that is assigned a value. But with lists, we can do that for multiple things. So I can say groceries is equal to ginger ale, chicken, broccoli, chocolate. And then if I say print groceries, I press Shift Enter, you'll see it'll print back out my list. Now, what if I just want to get a specific value out of my list? So print groceries, and I just auto-populated that, but print groceries 0, 1, 2, and 3. And you might be saying 0, what's up with that? Well, with Python, some elements, the first element is always 0. So your first element in a list or matrix is going to be 0. So ginger ale is technically the first element within our list, but in Python it is viewed as the 0th element. And our first element that we would grab, or technically our second, is going to be chicken, and our third, but our second, is broccoli, and our fourth, but our third value is going to be chocolate. So now if I run this, you can see just printing groceries, I get the whole list printed out. But grabbing the individual elements, I get my ginger ale, chicken, broccoli, and chocolate. Pretty straightforward. You can also append things to lists. So I can say groceries dot append. And let's say, what else do I want to buy? Ice cream. And now if I print groceries, what do I get? Ginger ale, chicken, broccoli, chocolate, and ice cream. What if I want to remove something from a list? Then I can say groceries equal to groceries minus, let's get rid of broccoli. No, we need the broccoli. Let's get rid of chocolate. And then so you can see that it just printed out broccoli. Here's -3 because I assigned what I removed from the groceries list. And I can also do that another way. Equals groceries. I could say 0 through 2, and then 4. So if I comment this out, it will not run. No, they don't like that. Chicken. And so you can play around with this and essentially remove elements or keep elements within your lists. You can also add elements as well, as we saw with append. The important thing is that as you work through this, you can essentially add or remove or pull certain elements at any time you want from a given list. Okay, next thing that we will cover are going to be dictionaries. So what is the value, or let's talk about dictionaries first. And I'll make a dictionary. I'll say grocery list is equal to, I keep hitting shift enter. I say budget is going to be 50 and comma, and then items are my items, comma, oops, and let's say a store that I want to shop at is going to be, we'll say Kroger. So now I press shift enter and I have a dictionary. So what is the value of a dictionary? Dictionaries are sometimes referred to as hash maps as well. And essentially what we've done is we've created a organized database that have key value pairs for the most part. So budget is the key, and the value is 50. our store is the key and the value is Kroger. And we can do this for a number of different things that we want to keep contained together but are still somewhat separate. And we'll find later on that sometimes it's helpful for a lot of different cases to do it like this, but there are also sometimes better ways that we need to utilize it depending on our purpose. So how do we interact with our dictionary? Well, print is how we do everything else. Grocery list. And I just want, the budget. And my budget is $50. So unlike with the list where we call a element number or value for where the element is within the list, with a dictionary we're calling the key to get the value paired with the key. So in this case we're calling budget to get the value 50. What if I want the items? Well, I can do the same thing. And what if I want just a single item? I can use my element selector, which is what I did up here for my list, and I can pull items and then one specific item. And so that kind of helps you organize your data. And if you want to keep things in a similar variable or in the same variable, but have them organized separately from each other, you can use a dictionary to do that. Again, not always what we would use for analytical purposes, but it can be helpful in certain situations. All right, next up, we're chugging along. We're going to go to functions. Functions are probably the most useful thing that you can become acquainted with in Python. A function essentially allows you to create repeatable code. So this is something that you can continuously call upon. Earlier in this exercise, you see that I did arithmetic, and I have to continually type out like big burger minus burger, burger plus big burger, so on and so forth. Well, with functions, you can set everything up so that way you don't have to keep typing it out and you can just run a single function. So let's say we're going to define a function, and to define a function we use def, which is short for, you guessed it, define. So we can say define combo meal. And it's going to take, we'll say X, Y, and Z. So when you saw the autocomplete probably had, burger, fries, beverage up there. You don't have to put those. You can put any placeholder. Basically what this is saying is that the function combo meal is going to accept 3 values and nothing less than 3 values. So you could potentially accept 2 values, and there are ways to make some of these optional, but by putting them in here, it is expected that you will feed the function at least 3 values. So with that, I can do a colon, which sets up the function, and when I hit enter, you can see I already have an indent underneath. And so this is essentially saying everything below def and that colon is a part of or belongs to that function. So simply put, all I'm going to do here is I'm going to say return x plus y plus z, right? And then, underneath that, we don't really need anything else. By saying return x plus y plus z, it will give us an output based on what we put in for combo meal. So now I can say print combo meal, and we can use big burger, fries, and beverage. And you can see the value output is 15. And if I go back up, my big burger costs $10, my fries is $3, and my beverage is $2. And if you sum all of that up, you get 15 bucks. So again, functions are very important, and they can help keep your code pretty clean. One of the things to keep in mind with functions is you do want to describe, and this is really where comments are helpful. You can really describe what the function does. So a function to sum the cost of a meal. And you can do different things inside a function. So let's say I wanted to provide a discount. So for buying a meal, we can do another one down here. Shift enter. Discount for meals or combos. So I can say DEF disc meal, and again XYZ colon return X plus Y plus Z. And let's say I want to give X plus Y plus Z minus, you're going to see it already auto-completes for me. Great. So we're taking 10% off of our meal. And if I print this out, I get 13. My meal is now $13.50. So this makes things very simple in terms of how we go about setting up our functions and how we go about conducting different operations and arithmetic. And now it's repeatable. I can create new menu items, and because I have the formula here, which takes our entree, side, and beverage, I can now just plug in any value there for a combo and get the discounted value off of that by running it through my function here. And so functions are very, very important to memorize. We will be using them a lot. Okay. I can also go over imports for different packages, but really imports are really just importing functions. So if I import math, I'll import the math library, which has a variety of functions. How do you know which functions are within the math library? Well, you'll have to use the documentation or Google it. And I've already pulled that up here. So I've Googled, the math library functions, and you can see all of the methods and functions that are already coded and produced within the math library. So math.a cosine, a sine, arc sine. We have pi down here in constant, math.pi. We can get the tangent. We can do the base log of a number, all kinds of functions depending on what we're looking for. So we don't have to actually write it out in Python. So just keep that in mind for importing packages. You can always import, and you can also import specific methods or functions. So you can say from math import star will give you everything, but you can ask for specific things like pi, for example. And now you can just say pi dot whatever in order to get a value. Okay, let's start with another thing that's going to be very important. So loops are the last thing. Loops. And there are two types of loops. There are for loops and there are while loops. Loops are crazy, man. No, I'm kidding. Loops are pretty straightforward. It is difficult to wrap your mind around loops at first for a lot of people. They tend to get confused with what a loop is. Once you learn what a loop is and what it can do, you'll realize the power of it once you start playing with larger data sets, because it makes it very quick to iterate through a list or a matrix. So let's say we have food prices. We have a list here. And our list is going to be 5.5, 10.5, oops, 20.5, 35.5. Let's say you order the the Ruth Chris burger, which is 100.5. All right, so we've got our food prices, and now what we can do is we can say for I in food prices, print I, and if I press enter, it'll loop through that list and print out every single value for us. So I don't need to select elements in that list. I just want to know what are all the values in that list and how can I print them out. You can also combine this with functions as well. So I could say print out, we could say disk meal I, and we can use some hard-coded values, beverage. And now you see our values have changed. We have a discounted meal that's looping through for the cost of each meal plus fries and a beverage. So our $100 burger with fries and a beverage will get a 10% discount, $94.95, once all of that is incorporated. And then for while loops are very helpful if you are trying to run code so long as something is true. So let's say we're evaluating food prices again. Oh, I won't make new food prices. We'll keep our food prices. Let's say we only have a certain number of discounts that we allow. So discounts equal to